All right, good morning. We are going to answer a couple more questions here on 12.1 Form G. I highlighted the questions in blue, 10, 12, 16, 17, and I think that's it. So number 10, I think, was problematic. This goes back to stuff we had issues with on I think Chapter 7 and Chapter 8. The Chapter 12 content of the question is just simply asking you, is this line tangent to the circle, which means we need to know if that creates a right angle, and then we find that out by using the Pythagorean theorem. I think the area where the students that emailed me, because I had multiple people email me with this question, are getting hung up on is squaring this. Okay, but before we get to that step, let's go ahead and talk about our setup. We have a leg, 3 squared, plus this is our other leg because we are believing this to be the right angle. And that makes this side your hypotenuse. So we have 3 radical 3 squared is equal to 6 squared. And I also think perhaps another area where this just occurred to me that you might be getting stuck on is some of you might think that from here to here is 3, making the entire hypotenuse 9. I unfortunately don't have a good way to tell you that by just posting an assignment online. This is a question I get very often. Obviously kids would come up to me in class and would say, what does the 6 represent? So I didn't do a good enough job, I guess, when I posted the assignment, that the 6 on this is the entire length here. So if you're getting hung up there, I'll make on your test very clear exactly what the hypotenuse is. So if you got this wrong because you claimed and thought, which is a rightfully made thought, if you said from here to here is 3 and from here to here is 6, and therefore you said this is equal to 9 squared, okay, that's fine if you got it wrong that way, because I would understand why. It's just not clear what the 6 is representing. Okay, but the 6 is representing that entire length. So this is our formula. So I think when you do this, if you're still having a hard time with this, you're obviously going to get 9. We'll talk about this, and it's going to equal 36. Okay, if you do this algebraically, think back to your Algebra 1 rules. You have to square everything that's inside of the parentheses. So it's really saying 3 squared times square root of 3 squared. Well, 3 squared is 9 times, and the square root of 3 squared, it just undoes itself, so it's just 3, which gives you the total answer of 27. Okay? If you don't want to do it by hand, well, then just go to your calculator, just type it in exactly as I do, hit a parenthesis, type in 3, multiplication button, hit the square root button, which will give you another parenthesis on some calculators. Then hit 3, close that parenthesis, and then you need to close this parenthesis and then square. It will also give you 27. Okay, again, if you're having issues with your keystroke or whatever it is on your calculator, I think your best move is just email me. And if I need to, I can set up like a quick Zoom or something just to walk you through the steps and type that in your calculator. But like I said, if you do it algebraically, this 2 hits everything inside of the parentheses. So 3 squared gives you your 9, radical 3 squared gives you your 3, and then 9 times 3 gives you that total of 27. So when you've squared everything in your Pythagorean theorem, you have 9 plus 27 equals 36, and that is a true statement. Okay, so that would be a yes there. Number 12 is the exact same thing. My assumption would be that the hang-up was, well, this one's actually a little bit clearer, because if the radius is 5.6, then this radius can't be 10.6. That will tell you it has to be the whole thing. But otherwise, if you know that 10.6 is representing this entire length, then your setup should be very straightforward. 5.6 squared plus your other leg is 9 squared is equal to 10.6 squared. Okay, so type that in your calculator. You should have no issue seeing that is a true statement, and having your answer there. And again, you're just asking, is the line tangent, which is asking you, is this a right angle or not? And you find that out by testing to see if this creates a right triangle. Okay? Moving on here, now these got a little bit tricky. The first two in this section, 14 and 15, were really, really easy. The reason why 16 and 17, I understand why they get problematic. You just remember the last theorem we talked about in our notes is that if you have two lines that are tangent to a circle and they share a common endpoint, those lines are congruent. So what does that tell me? Well, in this picture, if this piece is 4, then that piece is also 4. If this piece is 3, this piece is also 3. Now it gets tricky because they're asking for the perimeter of the entire figure here. Well, if this whole thing is 7, let me back up. The part that I need to figure out is this right here. I don't know enough information there to know really this piece is what I need. Okay, so what I do is I know that this and this are 4, this and this are 3. If this is 5, that tells me that from here to here is 5. Well, if the whole leg or the whole piece is 7, then this little piece remaining is 2, because 7 subtract 5 leaves me with 2. If that's 2, then this piece over here is also 2. Okay, so now we had to work backwards a little bit to figure out how to exactly calculate the perimeter, which of course is like I said, the distance around the entire figure. The only thing that I really needed to know was that this length was 2 to solve this, but I had to find all these other pieces to figure out that length is 2. So my perimeter now is, I'll do this in a different color here. This whole length is 7, this whole length is 9, this whole length is 7, and this whole length is 5. So 7 plus 9 plus 7 plus 5 should give you your 28. Okay? And then lastly, this was the most challenging of the 4, in my opinion. Again, they're asking you to find the perimeter of this figure, and you're looking at this and you're kind of like, all right, well, no problem. I already have 2 of the 3 whole sides. I just got to find this little piece to figure out this whole length. Then I can add them all up to find my perimeter. Well, easier said than done. In order for me to know how much this is, I have to work backwards. I would have to know how much this piece is. Subtract that from here. I have to know this piece, and I have to know all these pieces to figure that out. But once you get the first one, they all fall into place. So from here to here is given to you as 15. Well, that tells me from here to here is also 15. So if I take 24 and I subtract from it 15, because again, this whole length is 24, I just realized or found out that this piece is 15. I subtract that out. This leaves me with 9, which tells me that this side is also 9. Okay? So if I take, now that I know that this whole thing is 21, and I know that from here to here is 9, if I subtract 9 from 21, that tells me that this piece is 12. If this piece is 12, then that piece is 12. Now I know this whole length is 27. So take your 27, take your 24, take your 21, add them all up, and it should give you your 72. Alright, if you have any questions, shoot me an email, and I'll be happy to make another video.